Obviously, this is all about fossil fuel burning, which means when we talk about carbon footprint, we have to worry about what reserves remain and what happens if we burn them all. And the estimate of the remaining reserves is not easy, and the numbers differ. Plus, now we will see that the idea is not what happens, how much carbon we'll produce if we burn it all, but how much of it has to remain in the ground to avoid hitting some of these global warming targets like 1.5 degrees C or 2 degrees C. Okay, so just revisiting this total emissions a minute, we already looked at this in a different way. So here are the regions that are contributing it, and we'll see another figure which shows that China has slowly taken over as the leader. And if you just look at transportation, so we looked at sectoral emissions. So we said energy is almost 3/4. Then you have bunker fuels, which are used for various aviation purposes and shipping purposes and so on. Land use, land change, which we haven't addressed much, waste, agriculture, and so on. So if you look at energy, then electricity and heat, manufacturing, transportation, and other fuel consumption. So I'm just repeating this a little bit. But if you look at the total emissions, we already saw that carbon dioxide is most of it. Methane, nitrous oxide, and flue gases, F gases, contribute to it. China has now become the world's largest carbon polluter. So if you go back to the 1950s, world's top 10 carbon polluters in 2017, and the change in position since 1959 in gigaton CO2 equivalent. So you can see that US and Europe were dominating for a while. China was down here, and slowly with its economic growth, population growth, and its importing the manufacturing of the whole world, it has now become the largest emitter. But again, as we said, if you take embedded carbon, traded carbon, then obviously most of the countries are exporting their emissions to China, because China has become the manufacturing hub for everything. So India also has gone up in its total emissions from being very low down here to being now the fourth. So if you count the EU together, that's where it ends up. Russia has gone down, but that's before there was a Soviet Union, so you have to be careful where it switched from Soviet Union to Russia. Japan is another big one here, and so on and so forth. Okay, so what happens if we burn all the fossil fuel reserves? The estimate from this book is 2.5 trillion tons of CO2 equivalent. That's 50 years of current global emissions. 50 years of current global emissions. So we will not be running out of fossil fuels anytime soon, but one can think that maybe there's enough fossil fuel for us to find a solution to keeping the coal, especially coal and other fossil fuels, in the ground. That's called leaving the assets stranded, but the energy companies would see it as money just sitting there. They want to take it out and burn it. Okay, so coal, oil, gas, and total billions of tons of oil equivalent. Coal can last for many more centuries if we keep burning it at the rate that we burn, but the billions of tons of CO2 equivalent would be 1470. Oil 530, gas 520, and the total of 2.52 billion trillion tons of CO2 equivalent. 2.5 trillion tons of CO2 equivalent. These numbers differ, so I'll show you a couple of other estimates along the way. You can also look at it as years of fossil fuel reserves left based on the consumption levels. So years of global coal, oil, and natural gas left, reported as the reserves to product ratio, which measures the number of years of production left based on known reserves and annual production levels. Note that these values can change with the time based on the industry of new reserves and change in annual production. Okay, so oil companies continue to invest in finding new reserves, and the numbers say that the returns on those investments in finding new reserves is becoming quite low now, so they are not finding any new reserves at all for all the money that they are continuing to spend on finding the new reserves. So we have 114 years of coal based on the current reserves to product level ratio, but this number I have been so this is reserves to product, but the consumption level can be converted to number of years we can burn coal. I think that's much longer. Natural gas at 52.8 and oil at 50.7. If you look at it as energy reserves in billion tons of oil equivalent, how long can we keep going? Another way to look at it, so this is from this site from Stanford, coal, gas and oil, so you would run out of coal into the 22nd century, and then gas here and oil goes off earlier. Okay, so the point is that there are various other estimates for these numbers on reserves that remain. Obviously, transport is where most of the fossil fuels get used other than energy production. So if you look at transport emissions, road transportation is the biggest one. I won't go into the others, but the point is over time the consumption by road transport has gone up, which is not good news. So conversion to EV is being discussed a lot. EV is definitely less polluting, but unless the energy for charging the EVs comes from clean sources, you're not going to reduce emissions. You're just going to move it from burning fossil fuels for running internal combustion engines to burning them for producing energy to charge the electric vehicles. So we have to be careful about that as well. The other item that goes in here is the number of oil spills from tankers worldwide, which also results in emissions, air quality issues other than biodiversity loss and so on. Oil is a hydrocarbon. If you leave it alone, it'll be eaten up by many bacteria, and now there is also a bacteria that is synthetically produced and can be brought in cans or whatever and be thrown on the oil spills to hasten the consumption of the oil spills. But here in blue, the smaller oil spills are 7 to 700 tons, and large oil spills of greater than 700 tons are in orange. And the big accidents like the Exxon Valdez, which happened I think somewhere here, led to lots of changes in ships that carry the oil tankers, basically double hulls and many other rules and regulations. So good news is that the number of oil spills, small and large, have dropped greatly in number. Deep Horizon happened fairly recently and caused massive damage, and BP paid massive amounts of compensation as well. And the quantity of oil spilled from tankers worldwide has also dropped nicely. So quantity of oil spilled per year in tons has also dropped off. So the emissions from oil spills has dropped off. So the new arguments now being made is that most of the fossil fuels have to remain in the ground. Non-extractable coal, oil and gas reserves that must not be burnt in order to prevent dangerous climate change of more than 2 degrees C. This is from an article in 2015. I will show a later article which changes these numbers already, because we are not really reducing our emissions. Okay, so global reserves percent that cannot be burned: 82% of the coal reserves must stay in the ground. Here are where the reserves are. US has a lot of it. Africa, China, Australia exports almost all of it to China. China and India have a lot. US emissions seem to be going down, but you have to be careful because US exports coal. Okay, Germany gets blamed a lot that it appears very climate friendly, climate progressive and so on, but it is still digging up coal and actually making tremendous impacts on some villages for extracting coal. 49% of the gas has to remain in the ground. Middle East, China and India and ex-Soviet republics have a lot. Arctic has a lot, and this is bad news because with the Arctic ice melting, sea ice disappearing, many countries are beginning to think this could be a boon for digging up gas from the Arctic. Well, as we say, burning this up is going to create massive problems. Oil, lot left in Middle East. Canada sits on a lot, and the Arctic sits on a lot. Okay, so if you look at these numbers in 2020, this is from 2021 actually. 2015 study found that if the world is to stay below 2 degrees C of warming, then 1/3 of the oil, half of gas, and 80% of coal reserves must remain in the ground. Updated modeling to avoid dangerous warming above 1.5 degrees C now suggests that much higher proportions of fossil fuels must remain untapped. So 89% of the coal compared to 82%, 50-some% of gas to 59%, and 50-some% of oil to 58%. Okay, is this going to happen? Of course, as the old saying goes, the Stone Age didn't come to an end because they ran out of stones. So fossil fuel will not be eliminated because we ran out of fossil fuels. It'll be because we found other ways of doing business. Another way to look at it is to be optimistic and say, what if we had carbon capture and sequestration working at large scale? Well, with CCS, the reserves, this is the total gigaton CO2 now, 37% to 26%, how much fossil fuels emissions can be reduced, 65% to 32%. Okay, so this is in 2050 and this is in 2100. Okay, so these numbers are useful to look at just to see how urgent the issue is, how we are already in a crisis. Just to conclude, this is the global carbon cycle that we touched on when we looked at the volcanic emissions, relatively speaking to others, to debunk the myth that volcanoes contribute a lot. This is the fossil fuel CO2 burning here, and these are the sinks that are going down. So land uptake, ocean uptake, what is in the reservoirs as dissolved inorganic carbon, which is massive. There is photosynthesis and respiration exchange at the surface. Marine biota store a tiny bit. Organic carbon in the ocean is a large reservoir. Of course, atmosphere has 860 gigatons, but it's increasing at 5.1 gigaton per year, which is bad news. So land use change is contributing 1.6 gigaton CO2 per year. Vegetation holds some, soils and permafrost hold some, rivers, lakes, coasts and so on are exchanging. But you can also see the reserves here. Gas reserves, the range is massive, 385 to 1135 gigaton carbon. So this reminds you of what I said before in terms of the uncertainties on in how much fossil fuel reserves actually remain. Oil reserves 175 to 265 gigaton carbon in carbon amounts. Coal reserves 445 to 540 gigaton carbon. So burning all these is going to create massive problems for any reasonable target that we can think of. Another way to look at it, over time, from the Industrial Revolution, fossil fuel emissions contribute a lot. Land use change contributes a little bit. Where is it all going? Ocean and land take up quite a bit. A lot of it accumulates in the atmosphere, and there are some residuals that cannot be accounted for, which are often known as missing sinks. So you can see that the budgets have improved and the missing sinks have reduced, but still one has to know exactly where that CO2 is going. These are very firm numbers, especially the fossil fuel sources, because fossil fuel is the cash commodity that is tracked very well. So we know the emissions coming from there. Land use, there are some uncertainties, but ocean and land uptakes have uncertainties. CO2 in the atmosphere can be measured very accurately and precisely. So the residuals do remain an issue still. Okay, so that kind of concludes the various carbon footprints covered in this book. We will have an additional couple of podcasts on food, because food is a massive contributor and something that requires massive behavioral change if we have to reduce emissions. We have looked at meat emissions multiple times along the way. Beef, for example, always comes up as the most damaging to the environment, but how many people are able and ready and willing to give up beef? So this is an issue, and in general agriculture and food production systems emit a lot. So we'll have a couple of more podcasts on food production before we close out this particular series of podcasts on carbon footprints of everything. How bad are bananas? Okay.